All right, the intermediate value theorem. If a function is continuous on the closed interval from a to b, and the y value at a does not equal the y value at b, and k is any number between f of a and f of b, so it's a y value between these two y values, then there's at least one number c, an x value, in between a and b, could be a, could be b, so that the y value at c equals that whatever number k. I know that seems pretty confusing, but a picture is going to be worth 1,000 words here. So here's the f of a, and here's a. Okay, so there's this point we're talking about here, and this is b, and this is the y value that goes with b. So here's our just some made up function. Here's the y value at b, here's the y value at a. So f of a and f of b here. K is some number in between f of a and f of b. It could be anywhere, including here, anywhere along here down to here. And what the intermediate value theorem says is if you've got a y value here and a y value here, that the graph has to cross this place somewhere, at least once in between. So I think it's pretty logical that if you have a function that starts up here and it ends up down here, it's going to have to cross this number at least once. If it goes straight down, it's going to cross it once. It could go down and up and down. But that only works if this graph is continuous. There could be more than one place, but there is at least one. So that's what the intermediate value theorem tells you, is there's some value that's in between, intermediate, in between these two values. There's at least one place. And what we're going to try to do is sometimes try to find this x value that goes with the y value that's guaranteed to be in there. So it's called an existence theorem. It doesn't really help you find anything, it just proves that there is one there. All right? So here's a practical example. Suppose that a girl is 5 feet tall on her 13th birthday, and then when she's 14, she's 5 feet 7 inches tall. So for any height h in between 5 feet and 5 feet 7 inches, so it could be like 5 feet 1, 5 feet 2, anything between these two heights, there must have been a time when her height was exactly h. So between 13 and 14, her height must have been something like 5 feet 2 or 5 feet 2.5. And it's reasonable because human growth is continuous, and a person's height doesn't abruptly change from one value to another. So the intermediate value theorem only works with continuous functions. So obviously if we have this function that's discontinuous here at this x value, then obviously it could jump over that k. So even though f of a is greater than f of b and k is somewhere in between, because this function's not continuous between a and b, then the graph doesn't actually have to cross that point. It only crosses that point at least once if the graph's continuous. So that's one of the stipulations of the intermediate value theorem, the conditions, if f is continuous on the closed interval. So to be able to use the intermediate value theorem, you first have to decide or determine if the function's continuous in between a and b, and then you have to show that f of a does not equal f of b, and then show that k is between those two numbers, f of a and f of b. So there's three conditions. First of all, f has to be continuous. Second of all, f of a cannot equal f of b. And thirdly, k has to be between, and it could be the endpoints too. Then, so that's the conditions, that's the big if part. If that, then we know that somewhere there's a c, so that there's that x value exists, that c exists, so that the function would equal that k value. All right, so let's use it. Use the intermediate value theorem to show that the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 in the interval 0 to 1. So here's the a and here's the b they're telling us to look at. This is going to be the k, the 0, that's the y value we're looking for, and this is our function. So condition number 1, is f continuous? Well, it's a polynomial function, and we already learned that all polynomial functions are continuous, so f is continuous. And on the AP exam, if they tell you to use the intermediate value theorem, or does it apply, they'll ask questions like, does the intermediate value theorem apply here? You have to talk through these 3 conditions. F is continuous. Okay, let's find f of A, and let's find f of B, and show that they're not equal. F of A is f of 0. If you plug in 0, what do you get? 0 cubed plus 2 times 0 is negative 1. F of B, B is 1, so plug in 1. I can use the equal sign here because I actually did plug 0 into the function to get an actual value, but just try to use arrows as much as possible. Plug in 1 here, you get 1 plus 2 times 1 is 2, so 3 minus 1 is 2. So obviously f of A does not equal f of B, because 2 does not equal negative 1. So condition number 2 is met, and condition number 3, K has to be between f of A and f of B. Well, f of A was negative 1, f of B is 2. Is 0 in between there? Yes, it is. So condition number 3 is met. So that means that there is some place, some x value, in between 0 and 1 where this graph equals 0. So it's where the graph crosses the x-axis. So we're finding an x-intercept here. And we know that for sure, based on the intermediate value theorem, that there is at least one place between 0 and 1 that this function crosses the x-axis. Okay, so we verified that the intermediate value theorem applies, and now we're going to find that c, if we possibly can. So, oh, I didn't put a graph there. That one actually we can't find very well without a graph. So you would graph it and zoom in between 0 and 1 to find the value. Let's do one that's easier to find. So let's say we've got x squared minus 2x plus 1, and we want to find a value that equals 4 in the interval from 0 to 5. So this is our function. It's continuous, so that's condition number 1. Condition number 2, what's f of A? So what's f of 0? It's 1. F of B? B is 5. 5 squared is 25, minus 10 is 15, plus 1 is 16. So condition 3, is 4 between 1 and 16? Yes, it is. So we know somewhere between 0 and 5, we're going to hit the y value of 4, but we have to find the c. So by the intermediate value theorem, we've verified that it applies. That's these 3 conditions. So by the theorem, because these 3 ifs are met, the conditions are met, then somewhere between 0 and 5, there's at least one place where this function equals 4. So let's find it. So set the function equal to 4. Subtract 4 from both sides. And let's factor it and see if we can find a place. How about negative 3 and positive 2 here? So first times first is x squared. Outside's 2x. Inside, oh, that didn't mean, I meant to put a 1 there. Good thing I checked. Alright, so 1. Outside is 1x, inside is negative 3x, so that's negative 2x, and negative 3 times 1 is negative 3. So that's how it factors. So x equals 3 is one of them, and x equals negative 1 is the other. Those are the 2 zeros of this function. I mean, not those 2 zeros, those are the 2 places where this function would equal 4. If I plug 3 into this function, I'd get 4. And if I plug negative 1 into this function, I get 4. So those are the 2 places where this function equals 4. Now remember, we only want the one that's in the interval from 0 to 5. So we're going to throw that one out, and this is our final answer. That's the c value, the x value, which we call c, because we're trying to find f of c equals 4. That gives us a 4 for the y value. All right, enough talking. We'll see you tomorrow. Have a good night.